right, so next section up, we're still doing some simplifying, but what we're going to do is make it much more difficult to see what's going to cancel. So one thing I need to do is, let's go put the heading on here before I get ahead of myself. We're going to do 3.3, and we're going to be simplifying what we call rational expressions again. Let's just say fractions. It's easier. But you're going to start seeing some pluses and minuses going on. And one thing I really need to have you pay close attention to is watch this. Take my favorite number in the world, number dos, and add to it number 8, and divide the whole thing by 2. I don't know that there's anyone over the age of 10 in this entire world who would not be able to tell me that that is 10 divided by 2, and that's always been 5. And that's totally true. What you can't do, and I just said can't, look how bad it would be if you were to cancel these 2's. You would be saying that 2 plus 8, which is 10, divided by 2 is 8. It looks ridiculous, and it is ridiculous. And you would never do that, and I know you wouldn't. But the thing is when we start throwing variables in, and we start having things like this, what always happens is kids just start to cancel because they think, well, my teacher's always said it, and I've said it. If it's on the top and it's on the bottom, then I can cancel it. You can, but not when it's separated or living next to a plus or a minus. If so, you cannot start canceling. You consider this one whole chunk, and it might even help you to lock it in parentheses like this, but that's a whole chunk of stuff, and it does not cancel. It's not the same thing on the top as it is on the bottom. Even look at this. If x was a 1, on the top is a 3, 1 plus 2, and then the bottom is a 5, 1 plus 4, and 3 over 5 does not simplify. So there's no canceling that can happen when you have the pluses and the minuses separating things. So we're going to keep that in mind. We are going to write in big words, do not cancel anything next to a plus or minus. It has to be, let's go put this not in a box. Nobody puts not in a box. All right, so what do I do here? What I do is, let's put an example up, like 2x minus 8 over x minus 4. I do not start canceling the 8 with the 4. It's living next to a subtraction. I do not cancel the x's. They're living next to a subtraction. What I do is I factor first. Okay, and I'm going to be saying that a zillion times for the rest of this entire unit. Factor first. If you don't, you will fail this unit because you're just going to start being what I call a mad slasher, and you're going to be canceling things that have no right canceling. So what I need to do is factor the top. What goes into both of those? And the answer is a 2. So I pull out a 2 or factor out a 2. The bottom has nothing that I can pull out of it. But now you'll notice I have the same chunk on the top as I have on the bottom. I'm not canceling the x's and the 4's. What I'm doing is canceling the whole chunk of stuff. And the answer is 2. So that's the kind of factoring we're going to be doing, but we've got to remember how to do all our factoring. So the next one I'm going to bump up the difficulty a little bit here. What if I have 6x plus 12 over x squared plus 7x plus 10? I do not start by canceling anything. I can't cancel the x's, living next to a plus. I can't cancel the 12 and the 10, living next to a plus. Everything's living next to a plus and nothing cancels until I factor it first. So on the top, I've got two terms separated by a plus, but they both have a 6 in it. So I'm able to separate a 6 from the rest of it. And I get 6 times x plus 2. The bottom, nothing comes out of all of these, but I should recognize this from the last chapter that I can unfoil it into x plus 5 times x plus 2. Now that I've factored everything first, I get to cancel big chunks of stuff. Is there a 6 not living next to a plus or minus on the bottom? No. But there's an entire x plus 2 that I can cancel off. So my answer is 6 divided by x plus 5. And this is called simplifying the fraction. Notice how much different that is than simplifying 2 over 4. It looks a lot different, but actually it's the same thing because you break 4 into 2 times 2 and you cancel the same thing. That's exactly what I'm doing on these problems. It's just I've got to know how to factor before I can figure out what cancels. So we're going to just do 2 more examples, but on this worksheet I'm going to have you actually check it in little bits and parts. So let's do this. 3x plus 12 over x squared minus 16. We're going to do that one in a bit. And then we're going to do 6x plus 6 divided by, and on the bottom we'll put x squared plus, let's say 10x plus 9. I'm going to keep a lot of things with pluses in them today just to get the process down, but let's go take a look. On the top, I don't unfoil that. It's only 2 terms, but I note that there's a 3 living in here, and there's a 3 living in here, and I'm going to undistribute it, or divide it out, so that'd be an x, and 12 divided by 3 is a 4. When I go to the bottom, I might be kind of stuck because I'm like, hey, nothing can be pulled out of these two. However, it's a difference of perfect squares. That's x times x, and this is 4 times 4. So remember from a couple chapters ago that differences of squares break up into samers, samers, and opposite signs. Now that it's factored, I can cancel, and I end up with 3 divided by x minus 4. I'd actually like you to pause the video and try to do this one by yourself, and then when you're done, hit play again. So pause it right now. All right, hopefully you noticed on the top that you can pull a 6 out. When you divide a 6 out of both of those, you get 6 times x plus 1. On the bottom, nothing comes out of both of these. When I see 3 terms and nothing coming out of both of them, I'm thinking unfoil. And 9 times 1 multiplies to equal 9, while at the same time adds up to 10. So I have x plus 9, and then I have x plus 1. Now I get to cancel. So I factor first, and then number 2, I cancel any common factors. So x plus 1 was living on the top, x plus 1 was hiding on the bottom, and I get 6 over x plus 9. And then the question is always, well, can I take a 3 out of each of these? And the answer is no, because one of them's living next to a plus. So to repeat, and this one actually deserves a summary, I think. So let's go to the bottom of the page there where the summary is. First of all, make sure you never cancel if a term a number or a variable, whatever, is next to a plus or minus. What do? We factor first, and then when we're done, we are a mad slasher. You slash at the end, not at the beginning. So I want to just do one last one where I throw in some negatives, and then we'll see how that goes on the worksheet. So, and this one, some of you might get kind of hung up on because it's a little trickier, but my smartboard's really not very smart today. So my last example, I'm going to throw some minuses in here. Let's go x squared. I might have to be done here if there we go. So let's do x squared minus x minus 12 all over, and on the bottom I'm going to do 3x squared, and then I think I'll do minus, I'm trying to think of what I want to do, 12x. Let's see how we approach this one. First of all, do I start canceling stuff? No. Does the 12 wipe out the 12? No. We never cancel if it's living next to a minus or a plus, if any part of it. So nothing cancels. I factor it first. So I go to the top and I say, can I pull anything out of any of these? No. I insert the invisible -1 so I see it. This is a 3-termed one, so I go and I unfoil it. What multiplies to equal 12 that I can somehow get a 1 out of? Well, 4 and 3 comes to mind. Keep in mind I need to add up to a -1, so I need to have the negatives win out here. So I'm going to have an x minus 4 on the top and an x plus 3 on the top. I'm hoping one of those is living on the bottom so I can wipe it out. On this next one, is this a difference of perfect squares? No. 3 is not a perfect square, neither is 12. But both of those have a 3 in them and an x. So I'm going to divide or factor out a 3x. When I take 3x out of the first term, I get just x. When I take it out of the second one, I get a 4. Now I'm dividing each of these terms by 3x. Now what I can do is cancel common factors. So this wipes out this. My answer is x plus 3 over 3x. Can I cancel the 3's? No! Why not? One's living next to a plus. Can I factor the x's? No! Why not? It's living next to a plus. So that is my final answer. So the next worksheet you're going to grab is worksheet number 3. It's green. Put a G on there. It's green, and what I'd like you to do is do the first row. 1, 2, 3, and then have one of us check it. Okay? So first row and then a check. All right? Peace out, Girl Scout. Ha, I did that just for you, Mr. Bell.